Hi everyone. In this video lecture we are going to discuss a very interesting topic called decimals. So this is about introduction to decimals. Let's suppose we go to a supermarket. You go to a supermarket and after buying all those stationery items, the drinks, the food items and whatever you go to supermarket and buy. And when you go to the cash counter, the guy at the cash counter hands over a pay bill to you. Let's suppose that this is our pay bill, this is our bill, and there's item A and its price is there, item B and its price is there, and after all those prices, then there are certain taxes that you have to pay, and then there are certain cess, right? So after all those, your bill finally says that you have to pay 1078.75. Let's suppose this is your bill. If you look at this number, this is what actually a decimal representation is. You would be familiar with this portion only, 1078. But 0.75, what is that actually? 0.75. This is a decimal representation where 1078 tells you about the rupees, okay, rupees how much? 1078. And this 0.75 is telling you about paise, how much paise you have to pay. 1078 is telling you about rupees and this is about telling you about paise. Now we know that 100 paise is actually equal to 1 rupee, right? 100 paise is equal to 1 rupee, and on the basis of that only we have written this 0.75. How we write that? All these things will be discussed in a very detailed way in our next video. This is only about overview of decimal numbers where you encounter such numbers. So this 0.75 actually tells you the paise. Now if you will ask your adults or your parents or whatever, in the 80s and 90s, till 80s and 90s, actually we used to have the coins for paise. We used to have 5 paise coin, we used to have 10 paise coin, we used to have 20 paise coin, we used to have 25 paise coin, we used to have 50 paise coin, okay, and then we used to have, after 50 we used to have a 1 rupee coin, okay, which still exists. We have 1 rupee coin, but now these coins, that is of 5 paise, 10 paise, 20 paise, 25 paise and 50 paise, they don't exist anymore. And actually we used to go to a shop and we used to buy certain, let's say, notebooks, and at that time it would be like, our notebook would be like 10 rupees and 50 paise. So 10 rupees 50 paise. So rupees 10, we used to have a note of rupees 10. Let's say that we have a note of rupees 10, and then what about the 50 paise we had to give? So 50 paise either we can give through this 1 coin, or 10 coin of 5 paise, or 5 coins of 10 paise, or 2 coins of this 25 paise, or 2 coins of this and 1 coin of this, or 2 coins of this and 2 coins of this, and 2 coins of this. So that will make up 50 paise. So just I'm trying to tell you that what this paise actually means, okay? So this is what actually decimal representation. So if I give rupees 10 and 50 paise to the shopkeeper, then I'll write it down as rupees 10.50. okay, it tells that I have paid rupees 10 and 50 paise. So this is actually a decimal representation, one of the many examples. What other examples can we think of? Imagine that you have a digital weighing machine. Okay, Okay, and here is the digital display of that weighing machine. You stand up on this weighing machine, and then this weighing machine tells you the reading that your weight is 70.3 kg, kilogram. Now your weight is 70.3 kilogram. Again, this is a decimal representation just like what we saw here. Here this 70 is actually telling you about 70 kilogram. This is 70 kilogram. Kilogram. But what about this one? That is 3. So this 3 is actually telling you about the grams. The gram. Okay. This is telling you about kilogram, this portion, and after this point, that is the decimal point. This point is the decimal point. It's telling you about the grams. So here you have 3 grams. Okay. Now you would be thinking that what is actually gram? So you know that 1000 gram makes 1 kilogram. 1000 gram makes 1 kilogram. And on the basis of that, we have written it here. How? That will be discussed later. You can think of one more example. Like, let's say that you have this digital thermometer. You have this digital thermometer. And when you put this thermometer under your tongue, and here is the digital display of the thermometer. And this thermometer tells you that your temperature, body temperature is actually, you are having a fever and it is actually 100.3. Now, degree Celsius. This is degree Celsius. So your body's temperature is 100.3 degrees Celsius. What is this actually 3? So this is actually Celsius. This is the Celsius, and this 0.3 tells you what if 1 Celsius, if from here to here you have 1 Celsius, and if it is, divided into 10 equal parts, so this is 0.3 is telling you 3 equal parts out of these 10 equal parts. So it's actually about fraction. So again, this is a decimal representation, okay, where this 100 is telling you the exact 100 degrees Celsius, the whole 100 degrees Celsius, and this 0.3 is telling you of 3 portions of, if you divide 1 degree Celsius into 10 equal parts, then this 0.3 tells you the 3 portions out of these 10 equal parts. Okay, so this is an overview of what decimal numbers look like. Now you know that when we write any number, let's say in this case this is 1078. Okay, you know that in the Indian numeral system or the international numeral system, we are actually dependent on the decimal number notation. We use a decimal number system, where this place, the foremost right place, is actually what? Is actually, this is telling the ones place. This is telling you the ones place. This tells you what? The next to the right, it tells you what? This is the tens place. This is the tens place. This tells you what? This place tells you this is hundreds place. We have learned all these things in numeral system discussions. Hundreds place. This tells what? This tells you that this is thousands place. This is thousands place. This is thousands place. We know that in a number, every digit is actually at some number place, and each number place has some place value. So in a way that these digits are placed at certain number place or place value, this 0.75 should also have some place value, and yes, they do have the place value. So if this was ones, this was tens, this was hundreds, this was thousands, they also have place values, and that is for this, the first digit after this decimal point is actually tenths. This actually tenths. This digit next to the tens will be hundreds. This will be hundreds. Now, if you're thinking that what actually this hundreds and tens mean, so this we will discuss in our next video only in very detailed way. But I'm just trying to give you an overview of what place value actually is in a decimal number representation. So like in this representation where you have, if you just forget for a moment that you have this decimal number, just concentrate on this 1078. If this is ones, clearly this can be written as 8 times 1 plus. This is at 7. So this can be written as 7 times 10 plus. This is at hundreds. So this can be written as 0 times 100. And this is thousands. So this can be written as 1 time 1000. Clearly, the multiplication factor at the ones place is 1. The multiplication factor at the tens place is 10. The multiplication factor at the hundreds place is 100. The multiplication factor at the thousands place is 1000. That is actually the place value of the number place, right? This was ones, so this is 1. This is tens, so this is 10. This is hundreds, so this is 100. This is thousands, so this is 1000. In a similar fashion, when you will write these numbers according to these digits, that is 7 and 5, in a way we wrote these digits in terms of their place value, then this will be plus 7 is at the 10th position. Now tenths means that if you divide a segment into 10 equal parts, so each part will be the tenths, that is 1 over 10, a simple fraction. So this number 7 will have its place value as the multiplication factor for this place value will be what? 1 over 10. This is tenths plus. For this 5 is at the place value of hundreds. Hundreds means if a line segment has been divided into 100 equal parts, okay, so each equal part will be 1 over 100, a simple fraction. A line segment or anything has been divided into 100 equal parts, so each equal part will represent how much fraction? Will be 1 upon 100, and that's what hundredths means. That is one equal fraction of total 100 equal out of total 100 equal fractions, portions. So this is 1 over 100. So you can clearly see that like these digits have their place value and therefore they have some multiplication factors for that place value. In a similar fashion, these digits, that is 7 and 5, also have their place values as tenths and as hundreds. The tenths multiplication factor is 1 over 10 and the hundredths multiplication factor is 100. If after 5 it would have been, let's say you had, after 5 comes, let's say 7. So this will be plus 7 times, this is tenths, this is hundreds, this will be thousands. And the multiplication factor for this thousands will be 1 upon 1000. And what does that mean? It means that if there's a line segment and if you divide this line segment into 1000 equal parts, 1000, each equal part will represent 1 over 1000. 1 over 1000. Okay, this is a normal fraction. This is what the thousands mean, that the one portion out of 1000 equal portions will be equal to thousands. So the multiplication factor for this is 1 over 1000. Okay, if you focus on this one, I'll just underline this portion, this portion and this portion. Focus on them. You can see that the multiplication factor is 1 and then it became 10, then it became 100, then it became 1000. So every time when you are I'm circling this plus just to represent it from here. Your decimal notation starts. These numbers, these digits are actually in a decimal representation notation. So if you are talking about this one, that is this portion. So the multiplication factor for at the ones place is 1, then it became 10, then it became 100, then it became 1000. It means that if you're moving towards the left, every time the multiplication factor or the place value is actually becoming 10 times of the previous one. 1 times 10 is 10, so this is 10 times of this one. 10 times 10 is 100, so this is actually 10 times of this one. 100 times 10 is 1000, so this is actually 10 times of this one, and so on. But if you are moving towards the right, that is after this decimal notation towards the right, so this is 1 over 10, then it became 1 over 100, then it became 1 over 1000. So in this, if this was increasing in 10 times, this is actually becoming 1/10 of the previous one. This is 1 over 10, and then 1/10 of this 1 upon 10 will be 100, and 1/10 of this 100 will be 1000. Now all these things we are going to discuss in a very detailed way. Just wanted to give you an overview of what actually a decimal notation or decimal representation is. Okay, so if you are still not very much not convinced with what actually tens or this hundreds or thousands mean, so just wait for the next video. We are going to discuss them in a very detailed way in the next video. So see you in the next video.